NAT allows multiple networks to reuse the same private IP address space. Let's suppose that we have two networks. These networks might be, for example, homes, or they might be larger networks in regions of the internet where IPv4 address space is scarce, for example, in developing regions. What NAT allows these networks to do is reuse the same portion of internet address space. For example, a particular special private IP address space is 192.168/16. Other private IP address space is specified in RFC 3130. Now, obviously, these two networks couldn't coexist on the public internet because routers wouldn't know if they got a packet destined for an IP address in this space, which network the packet should be sent to. What a NAT, or a network address translator, does is take the private IP addresses that are behind the NAT and translate those IP addresses to a single globally visible IP address. Now, to the rest of the internet, network 1 appears to be reachable by a single IP address, 203.178.1.1, and network 2 is reachable via a single distinct global IP address, 133.4.1.5. Now, a host back here, say 192.168.1.10, might send a packet towards a global internet destination. Now, the key behind NAT is that this packet has a source port, and the NAT is basically going to take that source IP address and port, and it's going to translate it into a publicly reachable source IP address and port, and the destination will remain the same. That packet will make its way to a global destination, and the reply will make its way to the globally reachable IP address on the corresponding port. Now, when that packet with that particular destination IP address and port reaches the NAT has a table that knows the mapping between that public IP address and port and the private one that it rewrote to generate the corresponding public IP address and port. So it can simply now rewrite the destination IP address of this packet to the corresponding private address and port. NATs are popular on broadband access networks, small or home offices, and VPNs. There's a clear savings in IPv4 address space since there can be many devices in one of these private networks, and yet all of the devices that are behind the NAT only use up one public IP address. The drawback, of course, is that the end-to-end model is broken. Now, we talked about the end-to-end model in a previous lesson, and let me just remind you how NAT breaks it. If the NAT device failed in this instance, for example, the mapping between the private source IP address and port and the public source IP address and port would be lost, thereby breaking all active connections for which the NAT is on the path. It's also asymmetric. Under ordinary circumstances, it's rather difficult for a host on the global internet to reach a device in a private address space in network 1 or network 2 because by default, those devices in these private networks do not have public globally reachable IP addresses. So NAT both breaks end-to-end communication and it also breaks bidirectional communication.